Okay, so let's start talking about our graph. Today we're going to be talking about most typical graph that you'll come across, which is a line graph. Okay, and this typical type of graph, a graph is used to evaluate behavior. Time and behavior are the two variables considered. Each data point on a graph gives two pieces of information: when the behavior was recorded, or the time, and the level of behavior at that time, which can be in terms of frequency, duration, or possibly another dimension. Okay, there are 6 basic components to a graph, and we're going to learn those today, and as we go along we'll make SAFMED cards for them. So the first is the X and Y axis. Does anybody remember exactly where the X and Y axis are on a graph? Okay, I'm going to see if we have remembered our basic scientific days, but the x-axis is what we call the horizontal axis. I like to remember it as the horizon line, horizontal, okay? So that would be this long axis right here, x. And that would be pretty typical standard notation that you'd see on the graph. The y-axis is the vertical axis. And we're kind of missing a little bit over here, so I'm going to move our graph a bit. There we go. So I'm going to say y-axis. All right. Perfect. So, our x-axis usually denotes time. During which a behavior was recorded. So that could be sessions, days of the week, months. Then the y-axis label tells you the behavior that is being recorded. This could be disruptions per session, number of tantrums per day, depressive episodes per week. Okay? Now, in our example, we're going to be using the X and Y axis to denote how many SAFMED cards we are getting correct and how many we are getting incorrect. So for our y-axis, we will need to create an axis label. Can anyone guess what's going to go along our y-axis? Remember that our y-axis is going to be a number, some measurement, whatever it is, the behavior of record. And in our instance, what are we recording? Number of SAFMEDs. So for our y-axis, I'm going to put number of SAFMEDs. Number of SAFMEDs. Perfect. Now, when you label a y-axis, this is called an equal interval chart as well as a line graph. There are a lot of different types of equal interval charts. But it's an equal interval because each interval is going to be the same measure. But it doesn't always have to go up by ones, okay? It could go 2, 4, 6, 8, 10, maybe 5, 10, 15, 20, okay? But, or it could go 5 minutes, 10 minutes, 15 minutes, but it won't go 1 minute, 1.5 minutes, 10 minutes, all right? Equal intervals. So, number of SAFMEDs, we're going to go up by 2. Say 2, 4, 6, 8, 10, 12, 14, 16. All right. Now, we've got our horizontal axis or x-axis. And what does the x-axis measure? Time. So, what would be an appropriate label? Could we use a day? We could say day 1, day 2, day 3, but then that would really only limit you to being able to only plot one time. Instead, I think a better label for this might be test 1, test 2, or trial 1, trial 2. So that way, if you decide to test yourself more than once per day, then you can show that on the graph. So I'm going to say trials for our label down here. Trial 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, as I did that, I just reminded myself that we need to talk about something very important to graphing. And that's actually I'm going to make this look a little bit funny, but I'm going to add a new line here because I don't want to rewrite all of my numbers. Okay? And I'm going to call this baseline. Here is going to be a measure or a data point that shows my initial ability to identify SAFMED cards before I start actually quizzing myself and studying them using that shuffling process, okay? So that way we can get, all right, this is my initial knowledge base, and then thereafter, each time we study and we test ourselves, how many more SAFMEDs or how quickly we acquire our SAFMED and terminology knowledge, okay? So that's our X and Y axis. Let's make sure that we have a SAFMED card for it. All right, so take a SAFMED card on one side, write X axis, and then on the other side, you're going to write the definition. The definition describes the unit of time during which the behavior was recorded. And the horizontal axis. Okay, now take another card and write Y-axis on one side. Turn it over, and then on the other, the definition. The definition for the Y-axis is the behavior of measure and vertical axis. So we have our X axis, our Y axis SAFMED cards. So let's move on to the data points. Data points are going to be spots that you put on the graph to signify each instance that you measure your behavior of interest. Ours is going to be a measurement of how many SAFMED cards that we got correct or incorrect. The key to your data points is going to be located somewhere on the graph. Our key is off to the right over here, and typically it is off to the side of the graph, or it's under the x-axis. So for our purposes, our data paths, we're going to have two. We're going to have one that we're going to signify our data points using a triangle, and these are going to be number of correct, SAFMEDs, and then we are also going to have, we'll use the same color, we're going to have a circle. The circle is going to be incorrect. key. All right, so let's create a SAFMET card. I feel like we're going to be saying that a lot throughout this training, so we might as well get used to it and have fun with it. Kind of like, do you want to take a selfie? Do you want to make a SAFMET? Yeah, I know that was bad. Anyways, so let's create another SAFMET card for graph key. Graph key is going to be our term. And then our definition provides information regarding data points and the behavior of interest being measured. Okay, so again, provides information regarding data points and the behavior of interest being measured. Add it to our pile. Wonderful. All right, so data points must be plotted correctly to indicate the level of behavior that occurred at each particular time period. The information on the level of behavior and the time period being documented is taken from the data sheet or other behavior recording instruments. Sometimes the frequency taken from the data sheet or other instrument needs to be summarized or added together before a data point can be entered on the graph. For example, if disruptions were being measured during a 45-minute class, the total disruptions that occurred would be added and divided by 45 to obtain a number of disruptions per minute. For this reason, it is important that total observation time is noted so that these calculations can be made. Once the data point has been calculated, if necessary, each data point is connected to the next point by a line, and hence we'll get our line graph. If this didn't have lines connecting each data point, then it would be what we call a scatter plot. Okay? And we'll go into the variation in our lines and discuss trend lines and level once we've completed talking about our essential components here. All right, so that's our data points. Now, let's talk a bit about phase lines. So, I already drew in one phase line on here, but I'm going to draw it again in orange. So, a phase line occurs each time there is a change that may have an impact on a behavior. A vertical line is drawn on the graph. This phase change line can denote the move from baseline, where there's no modifications in the environment, there has been no intervention in place yet, just naturally what the current level or frequency of behavior is, to intervention or from one intervention to the other. Data points are not connected across phase change lines. In addition, phase change lines can be used to note other changes that may impact the behavior. This might be something like a change in a living situation, maybe a medication change, if the child was maybe out of school for a period of time. If these changes are temporary, then arrows are often used to mark the beginning and end of these temporary factors rather than phase change lines. So for our graph, we're going to take an initial baseline measure, and then we're going to draw a vertical line down for our phase change line. Now, every time you have a phase change, there's also going to be a phase label, so that you understand exactly what that chunk in your graph represents, or what phase of your graph that is. So our first phase is going to be our baseline phase, right? Prior to implementing an intervention. So over here, I'm going to write baseline. BSL for short. And then over here on this side, I'm going to write study. Intervention. So that brings us to our ability to create 2 more SAFMED cards. Our first SAFMED card is going to be phase line. Go ahead and write that as a term, phase line. And then on the back, we can provide a brief definition. A line drawn on a graph to denote a change that may have an impact on the behavior of interest to be measured. Okay. Next, we're going to do a phase label. Go ahead and write that term. Phase label. Okay. And our phase label, a label that appears at the top of each phase to describe the particular phase. Or treatment. Okay, so in some graphs, you might have multiple phases, especially if you were doing some sort of reversal design or a multiple intervention design, where maybe you're implementing one treatment, you're seeing if there's an increase or decrease in behavior, you're withdrawing the treatment again back to an original baseline, and then maybe you implement a different kind of treatment to see if there's a further increase or decrease. So then you would have obviously different phases, and then you would have different phase labels like treatment A, baseline, treatment B, baseline, treatment A, baseline, treatment B, baseline, okay? So it's very important that you have that information on your graph. All right, so that about sums up all of the important components of our graph. The one thing that we didn't put on here is a graph title. That would typically be at the top and briefly describe the information that is visually being represented within that graph. Ours might be something like intervention of SAFMED studying or effects of SAFMEDs on acquisition of terms. All right, so let's move forward a bit here. And we're going to talk a bit about things that you might see on the graph and how you can interpret graphic displays.